everyone, I'm Amy Judd.
Casey Lambert.
John Knapp.
We're representing AES, our mentors for this project for Graham and Ryan. The goal for our project was to create a residential subdivision. Our project is located in Williamsburg, Virginia on 3601 Rochambeau Drive. The acreage for the site is 14, and before those acres were undevelopable. They were undevelopable because there is a wetland on one side of the site, and there's also a very large resource protection area. Also, some of those slopes were very steep around the wetlands, so it was undevelopable. The soil for our site was not going to give us any trouble for developing. It's a sandy loam, hydrologic soil repeat, and there's also a utility tie-ins located on the east of the site. So the goal for this project was to create a residential subdivision. We tried to adhere to the James City County comprehensive plan. The comprehensive plan pretty much recognizes the need for growth and development, but it also wants to be sustainable in that. So we tried to include many low impact developments and best management practices in our site. It's zoned general residential. It should be a low density subdivision. The minimum house setback is 25 feet. The width of the setback line should be 75 feet. The minimum side yard is 10 feet, and the minimum rear yard is 35. For corner lots, the requirements were a little bit different. No structure should be 25 feet to the right of way, and the minimum setback line width should be 100 feet. And Casey's going to tell you about our conceptual layout.
For our conceptual layout, this is kind of one we chose. Didn't ultimately go with it. As you can see, it's more of a blocky style that ultimately you wouldn't see out in the real world. We did manage to get 32 lots with this. Managed to get pretty good green lot space with it. However, due to increased roads, it just seemed infeasible just to increase cost and by the guidance of our mentors, we ultimately went with more user friendly. And this is a rough of what our final product would look like. It is we ended up losing 2 lots going down to 30. We added a swell in the middle to retain some water or storm water to send it to our detention pond up in the corner there. And it looks more of a user-friendly, more modern kind of style than as opposed to our
So for grading, we had a lot of trouble with the grading. Our site was very flat. As you can see on the contour lines, the dotted ones, they're very far apart. These are 1-foot contours, not 2-foot contours. So most of the water flowed from the bottom right-hand corner to the upper left, which is right along that RPA wetland boundary. So obviously we couldn't let any water flow into the wetland. So when we first graded it, one of our goals was to get water to flow away from housings, which caused 2 major problems. One, water flowing down to the south onto someone else's property, and water flowing to the west into the wetland. To solve this problem, we added a long ditch or swale, which diverted all the water from the south and the west into the very large retention pond we have in the upper left-hand corner. We ended up getting a pretty good grade. We were able to tie in everything at a 3-to-1 ratio where we needed to, and we ended up getting sufficient storage volume. Our cut was a little over 7,000, it was 8,000. Our fill was a little under 4,000, so we netted in cut, which is good, because if you net and fill, it ends up costing more. And that's
So for stormwater management, one of the other things we said before, we had pretty good soil with low runoff potential. So that was kind of in our favor to begin with. So determining how much water is going to flow, we used the TR55 method and found peak discharges of the pre and the post development. And as you can see from the numbers, it basically doubled everything. So we added a detention pond in the northwest corner that would hold most, if not all, of the new storm water runoff that we were creating. But we also added a fire retention facility in the middle of our site that would help with slowing down the water and also help with some water quality as it was flowing throughout the site. And so with the pipe network, we kind of created 2 separate lines that went around the site divert all of our stormwater towards the pond.
For a potable water system, we ended up using a loop just because it was very easy for our site to create that loop. We had to have an easement along the west side of the site in order to access the pipe with a blow-off valve in the upper left-hand corner and hydrants here, and here. They will show up in a second. We calculated that we needed a fire flow of almost 2,000 gallons per minute. And so we tried to put 2 hydrants and ended up not covering the entire site. So we added a third one and we ended up getting a nice bunch of overlap. So that means every house would be covered. And they're located at the 3 intersections. The mains were 8 inches, 8-inch diameter ductile iron pipes, which connected in nicely to our existing water line, which is along the east side of our site. Our sewer system actually ended up being very difficult. On the bottom right-hand corner, there's a manhole that has a 20-foot depth tie-in. Originally, we thought that that would be really easy to tie into, but later we realized that since the lower elevation side of our site, the upper left-hand corner, was about a 10-foot elevation below this corner, and the sewer pipe already being about 4 feet underground, we only ended up having about a 4 or 5-foot drop. So we had to do a lot of finagling to make sure we had enough slope to achieve the minimum 2 feet per second velocity, which we did. And so we have manholes placed at every vertical or horizontal change in the alignment, and our maximum slope for the pipe was about 0.37%. We also used 8-inch PVC pipes.
For our erosion and sediment control, we wanted to be safe by not letting our runoff go over into other roads or the existing 4 lane of those. We're in the wetlands. We wrapped it with silk fence around the site, and we included diversion dikes to make sure that it tries not to run out the road, and we diverted everything up to our basin. We implemented 2 sediment traps along the middle, so when they get full and pond up, we were able to divert them on over into our basin, that we'll be able to withhold all water through our construction of our site. For phase 2, you see more after construction has started, just implementing more for emphasizing on diversion dikes, diversion dike up near the wetlands and along the roads again, just to keep everything from washing out of the road or trying to protect the structures that we put in.
So in conclusion, our main goal, especially from the comprehensive plan of James City County, we needed to basically balance the need for the development with sustainable practices. And we did that by incorporating a large retention pond and basically having little runoff off of the site. And also with the fire retention facility that we put in there. And so we had 30 total lots that we generated on the site, and our total cost was about $930,000, which we thought was pretty good. Is there any questions?
Brian, anything for these guys? The peak discharge that you gave, 5.74 pre, and I think it was 10.3 post, what return frequency was that?